MBF3C, grade 11 work or college preparation mathematics, and my name is Marvin. We had some technical difficulties there for a while. We finally got things figured out thanks to Jonathan. So now I have to find the document that I was sharing with you that I want to share. Okay, I'm going to move this up there. There we go. So thanks to Jonathan, we're on. A little less stressed out now. So I'm going to scroll down to where we finished off yesterday. So to date, we've talked about simple interest, compound interest, and we worked through problems involving the different formulas for the two different types of interest. And today we're going to move on to what we call annuities, which is slightly different, a little more complicated, it can be, but as long as we follow the steps that are outlined, we should be okay. So I'm just give me a second here now. Just closing the door so there's no interruptions. Okay, so we're going to take a quick, today we're going to start talking about loans. And once we get into loans and investments, we're going to talk about annuities and an annuity formula. These formulae look quite complicated. They're not. The most complicated part about this is making sure that you write down what you're given first, then write down the formula, then do your substitutions, and then the next most difficult part, if not the most difficult part, is making sure that you entered into your calculator correctly. If you have I'm not sure why there's a 2 up in my corner. I should make sure that I'm sharing the right screen here. Where is my Zoom? Everything looks different today. Okay, I'm not seeing that. So, Jonathan, can you verify that you're seeing the material that I'm talking about on screen? Because I shared the screen, but I don't see my toolbar anywhere negative. Okay, so what is going on now? I've shared my screen. Okay, so, okay, now we have another issue we have to figure out before we can move forward. What I'm seeing, I have two screens, Jonathan. I'm going to try moving this. I'm going to try and move it back onto this screen here. But I can't, for some reason, there's a green outline around the outside, around the perimeter of the screen, and it's showing me my document, but I can't access the toolbar. So if I go up or down, you're not sharing your screen yet on my end. Okay, so what I'm going to try to do is unplug that second monitor so it's no longer there, and then see if I can, for some reason, I can't get into Zoom. Okay, I may have figured it out, and I want to share, oops, that, and okay, now it looks like I'm sharing that, so now I just got to get up this material, and I'll have to go and so it looks like I'm sharing, but I'm not. It says your screen sharing is paused. So let's click resume and share and get the document up again. And you can share. I'm going to click on stop sharing for now, and then I'm going to try it again. Here, oops, this is being a pain today. Share, and I want to share this part right here. Okay, so now it looks like I'm good. Okay. If I'm not, Jonathan, just let me know. So we're going to look at lesson number 9 today, and we're going to talk about loans. Now, we're going to deal with formula that involve present value payments. So what we looked at so far, simple interest and compound interest, we looked at how much money you would owe if you borrowed money today and you were paid it into at a future date, or if you invested money and what you would have at a future date. But of course, as you know, if you borrow money, say, for example, you borrow money to buy a vehicle, you don't buy the money today and then pay it all back in 3 years from now, one lump sum. You make monthly payments. So that's what these formulas we're going to look at today deal with. We're going to deal with monthly or usually monthly. You can go weekly or bi-monthly or things like that, but that's the idea. Okay, so I'm going to, the material that you received, there are some examples which I'm not going to work through because I want to work through some other ones with you to give you more practice. So before we get on, let's talk about it. Let's do a quick review on what simple interest was. And don't forget that simple interest, minimize that. Simple interest, what we had to do first of all was to home here. What we had to do first was do the calculations for I equals PRT. So we had to determine the amount of interest first, and then we had to, it's probably quicker if I just do it this way, and then we found the amount at the end. So A equals P plus I. That should be, we don't want those underlined. So I equals P times R times T helps you find the amount of interest, and then A equals P plus I would give you the amount at the end of the period. Okay? So we found the interest first, then found the amount after. When we do compound interest, it's kind of done in reverse order, where we find the amount first. So in that one, the amount was equal to P times 1 plus I to the power of N. So we didn't actually find the interest first. We found the amount of that would be due at the end of the period. And then what we did, we found the amount of interest after, which you can find by just simply rearranging this formula here. So I was equal to, go this way, A minus P. The amount of money minus the principal will give you the amount of interest. So those are the two forms that we've been working with so far. And as each of these, so for example, I equals P times R times T, there are 4 variables. So as long as you know 3 of the 4, then you can solve for the 4th one. Same thing down here. We have 1, 2, 3, 4 variables, A, P, I, and N. As long as you know 3 of the variables, you can solve for the 4th one. Okay, so now we're going to get into loans. What exactly is a loan? And again, this is blue material, so it's new material. So what is a loan? A loan can be described as money or other material goods that is given to another party in exchange for future repayment of the loan value plus interest and other financial charges. So when you borrow money, you have to repay it. And when you repay it, you pay back more than you borrow. That's how banks make their money. So you borrow 10,000, you might end up paying back over the course of the 2 or 3 years that you're paying it back, you may pay back $12,000 or $13,000. So the bank is making a profit by loaning you money. And they charge you interest, otherwise they wouldn't make any money, and then they couldn't stay in business. A loan can be for a specific one-time amount, which is normally what it is, or it may be open-ended, like a line of credit that has a specific limit. So, for example, you could get a line of credit for $5,000 and it just sits there, kind of like in an account, almost like a savings account, and you can spend it whenever you want, up to 5,000. But once you start spending it, you have to start repaying it at the same time. So a month after you spend, let's say you spend $1,000 of that $5,000 limit you have, then a month later you'll have to make a minimum payment, and the minimum payment might be 10%. So you might have to make a minimum payment of $100 the following month. And if you don't borrow any more money, after 10 months or 11 months or 12 months, to be all paid off. But you could still, make a payment, then use more. But as long as you don't go beyond the $5,000 limit. So loan is debt. Debt is money that you owe. Okay, so you have to keep that in mind, and you do not want a lot of debt. So it's usually it's an individual or sometimes an entity, which could be a business. So if you have a small business or a large business and you borrow money, that would be considered debt. The other party in the transaction is called the lender. So the bank, if you get your money from the bank, they're the lender, or if it's from a credit union, they're the lender, or you might get it from the government, you might get it from the band council. Whoever you borrow the money from, they would be the lender. You, the person who is borrowing the money, would be the borrower. So borrower and the lender. So the borrower agrees to pay a certain amount of money over a certain period of time. So typically these, like for a loan, for example, you would borrow $10,000, buy a vehicle, and then the bank would do the calculations based on what the interest rate is at that time, and then plug it into a formula to tell you how much your monthly payments would be. And we're going to take a look at some of those examples a little bit later. How does the loan process work? Well, you don't just walk into a bank and ask for money, they give it to you, especially large sums of money. So you apply for a loan, and then you are required to provide specific details, such as why you need the loan. You will have to disclose your financial history, usually your social insurance number, and other information which may vary from lender to lender. So they're going to want to know, for example, where do you work? How much money do you earn each month? Can you give me a pay stub to verify how much money you earn each month? Or how much money do you earn in a year if you're a salary employee? Can you provide me a year contract? So what they want to know is, if I lend you the money, can you make the monthly payments? If you can't make the monthly payments, then they won't give you the loan. So typically what they do is they look at how much money you earn in a month, and depending on what you're borrowing the money for, they may say if you borrow more, you can't borrow more than, let's say, 30% of what you earn, because you're going to need about 70% for your, living expenses. So your rent, your groceries, your gas, your insurance, all these other things that you have to pay for. So they're not going to give you money or lend you money if you can't make the monthly payments. So then they're going to review your application. And then a lot of times they'll do what they call a credit check. And a credit check, you have a credit score. Everyone does. There's a couple of companies that do it, and it's based on, so if you borrow money or you have a credit card, um, then you're being tracked by a couple of companies. And what they do is they track, are you making your payments on time? If you're missing payments and you're being reminded, then you're going to have a lower credit score than someone who makes their payments every month and has never missed a payment or never been late for a payment. So if you get a good credit score, you're more likely to get the loan. If you have a low credit score, then you're not likely to get the loan. Once it's been decided that yes, you can possibly have a loan, then you're going to have to sign some contracts. Okay, and it's important that you read the terms of the contract. And if you're not quite sure, then ask someone to go with you or ask to have the contract to bring it to someone who does understand and have them read to make sure that you're not getting ripped off. Okay. Many reasons for getting a loan. The most common one would be to buy a vehicle, buy a snowmobile, buy a quad, large items that cost several $1,000s, and you may not have the money in the bank at the moment to make that payment. So for example, you buy a new car today, you're looking at $20,000, $30,000 minimum, and not a lot of people have that kind of money in their bank account. So they need to basically give them the money up front, and then you're going to pay it off over time. What would be a better idea if you could wait would be open a bank account, put a certain amount of money, whatever the monthly payment would be for a car, put it in the bank and earn interest on the money. And then at the end of the 3-year period or 4-year period, you have enough money to pay cash for the car. But that is not feasible, and not a lot of people are able to do that. So they end up getting the money up front and then making monthly payments to pay it back. So we're going to talk about a term or a couple of new terms here. So it's important to remember that in the formulas we've been using before, we use A as the amount in the future and principal as the amount we're starting with now. So if we borrow money today, that would be the principal. Well, now that term is going to change to present value. So present value would be the amount in the present right now. What would the value of it be? And then we're going to look at a bit later a term called future value. That would be the A. I don't know why in mathematics they decided to change the letters and make the terms different, but they have. So we have present value. We're going to talk about future value a bit later. And there's also a term that's called R. R, in this case right here, as you can see on the screen, would be the regular payment, or the regular payment you were making, or if you were, let's say, like I'm ready to retire in about 6 months, no, 8 months, I guess, 8, 9 months from now, in the June. So I'm going to be deducting money from my RRSPs. It's going to be done the same way. Instead of making payments, now I'm taking money out. So it will be the same formulas. So we have two formulas, and again, they look complicated, but the PV, the present value, is simply the principal. Look at it that way. R is the monthly payment. 1 minus 1 plus I is the same as it was in the compound interest form, is the interest rate per period. N, The letter N is the same thing as the number of compounding periods in total. So you notice that we have PV equals R bracket 1 minus bracket 1 plus I bracket to the power negative N bracket all over I. So if I wanted to know how much money I would have to start with now, how much money I would have to borrow now based on making monthly payments, I would use that formula. But this would be the formula that would most likely be used, the R one. R equals PV, which is present value, times I over 1 minus 1 plus I to the power negative N. And that formula will give us what the monthly payments would be. And again, that is most likely the one that you are going to be using. Okay, so let's scroll down a little bit. Let's take a look at some examples now, and then once we start plugging some numbers in, and again, the formulas look complicated, but look what I did. I wrote down what I was given. So in this case here, problem 9.1 says Clyde wants to buy a used snowmobile. Determine the equivalent cash price, or in other words, the present value, what value it would be right now, and the amount of interest paid if he makes 36 monthly payments of $267.90 at an interest rate of 12.4% compounded quarterly. So there's a lot of things going on here. So in the formula, PV equals R times 1 plus I to the power N, we need to know three things in order to use any of the formulas we've been dealing with. Even for simple interest or compound interest, we need to know three things. So if we look up here, and remember, compounded quarterly means, let me put this in bracket again, that's going to mean 4 times per year. Okay, 4 times per year. So the R value, that's the simple one, right? That is, what's the monthly payment? And the monthly payment right here, monthly payment is $267.90. So this is the R value. The N value, it says 36 monthly payments. So we don't have to do any calculation because it tells us how many monthly payments there were. They were 36. But we do have to do some calculations for the interest rate, because the interest I is the interest per period. And this is 12.4% per annum per year. So 12.4% divided by 4. So again, as I said earlier, whenever you're working through these problems, put those numbers into the calculator. 0.124 divided by 4 equals 0.031. And again, these numbers have to be in decimal format. So 12.4% would be 0.124. So remember, 12.4%, to change that to a decimal, we will simply divide by 100. Okay. So now I have my R value, my N value, and my I value. So the solution now will be, first of all, write down the formula. So the formula for now is always a good idea to refer back up here. So R equals PVI over 1 minus 1 plus I to the power negative N. Actually, no, we're looking for the PV, so we're actually using this formula right here. Okay, so there's the formula. PV equals R times 1 minus 1 plus I to the power negative N all over I. There's the formula. Now, again, do the substitution. So I'll just put a little note over here for you. So formula first. Okay, and then it's going to be substitutions. So what do you know? And then it's going to be simplify. You can learn how to spell there. Simplify, and then just do the calculation. Okay. So let's do the substitutions. We know that the R value right here, that's the first thing we got to put in. R is 267.90, bracket 1, and that 1 minus, bracket 1 plus, I is 0.031 to the power of negative, n is 36, all over I, and I is 0.031. So now we're going to simplify, because 1 plus 0.031 is 1.031. Everything else we're going to leave as it is. And we're going to leave it as it is so we can enter it into the calculator that way. So the way I do it is we have to do what's inside of the brackets first, and we have two sets of brackets here. We have a bracket inside of a bracket. Now, inside the bracket, we have to do the exponent part first. So we're going to go 1.031 to the power of negative. Now, you have to be careful on the calculator too, because sometimes the negative is different than the subtraction sign. Negative 36. And it's that case here. So where is the, so I'm going to go looking for it now, where the negative sign is. I'm using a graphing calculator. I'm not sure what you have available to you. I'm just, haven't used this for a while, so now I'm just looking to see where the negative exponent would be, or the negative symbol is in a bracket. It's one of those days. Okay. Oh, I can see it right down there. Okay, so 1.031 to the exponent negative 36, and you'll get 0.3318700013. Now, we had to go 1 minus that number, so I have to go, I'm going to put that in my memory. I go 1 minus what's in the memory, and then I get 0.66681299987. Okay, so I've done that, 1 minus that. So now the next part on top is to multiply that times 267.90. And then the last step is to divide that by 0.031. And I get 5,762.554915. I'm dealing with money. So when I got to do my calculation and round to nearest cent. Okay, so when I round 0.554, 4 is less than 5, so I leave it as it is. So it's going to be $5,762.55. Okay, so that's how much you would be borrowing today if you're making $267.90 payment for 36 months. Now, if I make 36 payments of 267.90 times 36, I'll get $9,644.40. So I borrowed 5,000, or sorry, Clyde borrowed $5,762.55, but paid back $9,644.40. So the amount of interest will be the amount paid minus the present value. So I go 9,000 $644.40 minus $5,762.55, I'll get $3,881.85. So the amount of interest that was paid back, or you would have paid back, is $3,881.85. So you can see that if the interest rate and 12.4% would be high, interest rates are nowhere near that right now, but at one point they were. But you can see I just borrowed, or Clyde just borrowed $5,700, but paid back 96. There's a significant amount of interest you're going to pay. Now, it might not all be interest. Some of it might be interest, some of it might be, there might be fees you have to pay, and so on. But that's how you would figure out how much you borrowed and then how much you paid in interest. Okay, so that, again, the formula is write the formula down first, then do the substitutions, simplify where you can, and then it's a matter of figuring out how to enter those values into the calculator. So I've double checked, triple checked my numbers. So I've done this problem many times. So I'm pretty confident that those numbers are correct. So when you do your calculations and you're not getting those numbers, so if you do the present value formula, plug all the numbers in, put it all into the calculator, and you don't get $5,762.55, then there's a mistake somewhere. So it may be just a way that it was entered into the calculator. If you can't figure it out, give me a call, text me, email me, and we can touch base and I can walk you through the steps, depending on the calculator you have. So once I know if you're using a graphing calculator, a scientific calculator, whatever you're using, then I can help you walk you through it. Okay. So again, these formulas are not, I wouldn't call them simple. This is not like simple interest. But follow the steps just like later there in red, and you should be okay. So let's look at a different problem now. And we might not get a chance to finish it, but we're going to start it anyway. Sample problem 9.2. Charles buys a truck for $24,500. He makes a down payment of $1,000 and finances the rest. He plans to make monthly payments for the next 4 years at 9.6% compounded monthly. Monthly means, again, put this in red, it means 12 times per year. So that means there's going to be 12 times per year where you are, let's just get this here in red as well. Okay. So now we have to figure out, we know what the present, present value is close, but he's borrowing 24,500, but he's putting $1,000 down. So that's where this is coming from. The present value is going to be 24,500 minus the $1,000 deposit or down payment. Subtract those two and you get the present value of 23,500. So that's how much money he has to repay. The interest rate is the interest rate per period. So we need to know the interest rate per month. So it's 9.6%. Again, take 9.6, divide that by 100 is 0.096. That's the interest rate as a decimal. Divide that by 12 and you'll get 0.008. That's the I value. And N is the number of payments altogether. 4 years. Monthly means 12 times per year. So 12 times 4. 12 months in a year for 4 years. is 48 payments. So you're going to borrow 23,500. Interest rate per month is going to be 0.008, and the number of payments is 48. So now the next step would be I didn't write it down here, I'm going to write it down now, solution. So the solution, and again, it's going to be underline and just following the same procedure as, let's see, get that B out of there. Okay. So the solution first step, again, is the formula. The formula, we're solving for the monthly payments. So the monthly payments, as we said before, is this formula right here. So R equals PVI all divided by 1 minus 1 plus I to the power negative n. So there's the formula. Oops, come down to here. There's my formula. R equals PV times divided by 1 minus 1 plus I to the power negative n. Do the substitution. Present value, right there, 23,500. The interest rate I is 0.008 over 1 minus bracket 1 plus I is 0.008 to the power of negative n is 48. If you do the substitution or do the simplification on the top, so again, first step, why does it do that? Undo that. Oh, well, for some reason it keeps doing that. So the first step is to do I'll do it up here. Formula first. Make that red as well. So do the formula. Then we're going to do the substitution. Actually, it should be substitution because it's more than one. You're going to be substituting 3 different values. So you're going to substitute the PB value, the I value, and the N value. Then we're going to simplify. And then we're going to do the calculations. And of course, round to the nearest cent. Or nearest penny. Okay. So we've done the substitutions right here. 23,500 times 0.008 works out to be 188. And then 1 plus 0.008 is 1.008. And then we leave everything else as it is. Now, from that point there, we're going to leave it as it is. And then, because if you do the calculation on the bottom, you're going to get a very large decimal number. And whenever we're working on these sorts of problems, we don't do any rounding until the very final step. So if you do any rounding, if you round off up here in the second step, you're going to get a rounding error. You won't get the correct answer. So here, I'm going to do, there's a couple of ways of doing it. I'm going to do it. So we could look at this as everything on the top is by itself, is inside of one bracket. Everything at the bottom is inside of a different bracket. So I'm going to try it this way. I'm going to walk you through it. Turn the calculator on first, though. So 188 divided by, make a bracket. Okay, everything underneath, 188 divided by everything underneath the bracket. I need to put all inside of it. Sorry, everything underneath in the denominator needs to go inside of a bracket to keep it all together. 1 minus, and then another bracket, 1.008, close that bracket, to the exponent negative 48, and then put another bracket there to close that bracket, and then press enter, and I get 591.516571. So round that to the nearest cent, or nearest penny, it would be 591.52. So again, Charlie's monthly payment will be $591.52. The next part is how much interest does Charlie pay on the loan? Well, the interest will be how much money he pays back in total minus how much money he borrowed. Okay, so how much money did he borrow in total? Well, the amount paid is going to be $591.52 times 48. He's making 48 payments of $591.52, works out to be $28,392.96. And then if you subtract the amount of money you started with, or the present value, or the amount that you borrowed of $23,500, you will get $4,892.96. So Charles will pay $4,892.96 in interest. Okay, so that is as far as we are going to get today. The formulas can be they can look complicated, and I will say they're not simple. They are fairly complicated, but as long as you follow the steps that I've laid out for you, you shouldn't have any difficulty getting through them. And again, if you're having trouble, it's most likely going to be with the calculator. And it could be depending on the calculator that you have in front of you. So again, if you're having trouble with the calculator, you can give me a call. I can walk you through it. And otherwise, you can possibly ask the DEC in the Learning Center, or if I'm sure there's people at WASA, if you call, that can help you as well. So that's as far as we'll go today. I look forward to talking to you again next week. Or sorry, tomorrow. Bye for now.